Hi, I'm Tim Berglund with StarTree. Welcome to Pinot 101, Upsert. Now, to think about upserts, let's just remember a few key facts. One is that offline segments are immutable. Now, real-time segments, or at least the consuming segment of a real-time table, can be appended to while it's being consumed, but once it's flushed as a segment, well, those are also immutable. Segments are things that we write once and we never change again. And while we're ingesting streams of events, like say clickstream data or some IoT device phoning home, that's fine because those are events and events never change. But what if we're doing something like consuming a stream of orders and those orders are rapidly changing status and we need to compute real-time analytics on orders with respect to other objects and other kinds of event streams in our system? Those are mutable entities. Those are things in the world that change. And in that case, the lack of an upsert capability really becomes a blocker. And once you start to think about it, to make a credible claim to be a real-time analytics database and not be able to handle entities in the world whose state is rapidly unfolding as events happen, you kind of almost need an upsert capability. You need a strong upsert story to have a credible claim at the title. Now, upserts, this makes complete sense once you start thinking about it, only apply to real-time tables. This is not a thing for offline tables. Offline tables really are ingesting accounts of things that have happened in the past and are not going to change. But for real-time tables where we're ingesting from an event stream like Kafka or Kinesis or something like that, we have the capability of enabling upserts. The way this works, I want to peel back the cover and just kind of talk about how it works a little bit, is that for each table, the server that's consuming that consuming segment, it's being the Kafka consumer for that real-time table, maintains an in-memory metadata map. And that metadata map points to, in effect, the most recent value for a given key. Now, there's a lot of words in there that could mean a few different things. So let me just walk you through some animation. Here's a server, and this is all within the context of a single table that this server is thinking about. So it's got that metadata map for this one table. And we're going to drastically simplify what our data looks like. Now, that's a row. Okay, that's a whole message being ingested from Kafka. It's a real-time table. That's all you got. But we're looking at it as a key value pair because, in the case of upserts, I have to define a primary key. So of all my columns in the schema, the object that I'm ingesting from Kafka, one of those columns is going to be defined as a primary key column. And that's A. That's the thing I'm showing as A right here, just to keep it very simple and very visual. And the whole rest of that row is, in this case, boom emoji. Again, that's going to be a number of columns. This is not a key value store here. It's still a row, but I need to simplify it so we can kind of walk through what happens here. The primary key is A. The value of the rest of the row is the boom emoji. So we ingest that and we write that to segment 1. Good deal. Also, in the process of writing it, it gets assigned a doc ID. Monotonically increasing integer, we're just getting started. That doc ID is 1. The metadata map says for primary key A, again, this is in the context of a single table, primary key A lives in segment 1 and has doc ID 1. Hey, let's keep going. Okay, so B, potato emoji. The primary key is B, the symbol for that row is a potato emoji. Great, write it into the segment, it looks great. Notice I'm skipping the consuming segment here and we're simplifying some things a little bit just to get the concept across. But if you have watched the module in real-time ingestion and you know how the consuming segment works and how it relates to segments on disk, you can kind of see the picture. That second row gets written and it has doc ID 2 into the metadata map, key B, segment ID 1, doc ID 2. Let's keep going. C, key C, great. Movie camera. That is doc ID 3 into the metadata map. This is great. But wait, it's not so much fun anymore. We are rewriting a key. We've already seen B. B used to be potato, now B is rocket ship. Well, I don't get to go rewrite things. I just get to append things. So I'm going to append that now into the segment, the B, the existing potato version, doc ID 2 I have. can't change that. So I'm just going to write this, give it doc ID 4, and update the metadata map. So now I know that key B is doc ID 4, which is rocket ship. So I've effectively upserted. I've been able to change the value of that key in a performant way, and even better, a way that's invisible to me as a user. I've just pointed this at a Kafka topic and I'm running queries, and I don't have to think about special jobs to run or workarounds or anything crazy like that. It's just a table that it looks like I get to rewrite keys. Oh, hey, lucky me, I get a new key, and looks like that's getting written to a new segment. That's a red flag. No offense to that poor key D, but now you see we have a new segment number in the metadata map, and A is getting rewritten. But again, all we can do is append. So we append A, which is now Moneybag. It gets the new doc ID, and we update the metadata map for key A, and so on. We can still write new keys. They get appended to the metadata map. We can still update old keys, even if we've updated them before. Suddenly B has been rewritten twice. It's occurred in the stream 3 times now, and now it's the VHS emoji. Graphically, and again, making some simplifications, kind of taking the consuming segment out of the picture just for purposes of illustration, this is how Upserts work in Pinot. And it is really a game-changing piece of functionality. There's certain kinds of operations that you just can't really do without this. You can't fully be a real-time analytics database if you can't keep track of entities that evolve over time. Upserts originally, as it says on the tin, support rewriting of a given primary key value, which if originally ingesting that key is like insert, that's like adding update in SQL terms, hence Upsert. Well, a delete is like adding delete, and it's required if you're ingesting, for example, a change data capture feed from a database. That's a kind of event stream that you might want to ingest, and you can't really completely do that if that table is going to take deletes, and deletes show up in that CDC feed. Without delete support in Pinot, those mean nothing, and your Pinot version of the data is going to be inaccurate. So if you need to make things go away, this feature is necessary. Now, recall that each server maintains a metadata map. We just covered that. And historically, that metadata map points to the segment, doc ID, and timestamp tuple. I wasn't showing timestamp in the animation, but it's there to resolve some late arriving data problems. And that map entry points to the most recent update, the most recent value of the key. Well, now basically what we're doing is we're agreeing sometimes we can put a tombstone there. If we see a delete, we're going to mark that metadata map entry as saying, stop, this thing doesn't exist anymore. Have we made the old values go away? Well, not technically, but we're not going to report those results anymore. So we're going to treat it like it's been deleted. So if we go back here to our metadata map and our segments, we've kind of got some data, and looks like B has been consumed a couple of times, and now we're going to delete B. So we've got this delete that comes in, and we write that to segment 2, and that is an entry. That is a thing we append. It gets a doc ID. It's a full-fledged document, even though it's just saying, hey, this thing is dead. Now we mark in the metadata map that key B has been deleted. We effectively put a tombstone there. So that is what delete means. So that, at a very high level, is how deletes work in Pinot. So there you have it, upserts and deletes. Very important features that really unlock critical use cases in the broader world of real-time analytics, and they're things that work natively in Pinot.